All right, question number 4, no calculator. Very specific directions. You need to simplify answers. So you're not allowed to leave log base 2 of 8. You got to know that's 3. You got to know the cosine of pi over 2 is 0. You got to know the sine inverse of 1 is pi over 2. You need to simplify. You need to use log properties. This is probably the hardest question, number 4. So practice this question. All right. Functions g and h are given by this. Rewrite g as a single logarithm base 3 without negative exponents in any part of the expression. Your result should be the form of log base 3 of an expression. Okay, so we need to use log properties to understand how we can do this. Some properties, products becomes powers of powers, just like exponent rules, and then sums become products. So log base 3 of x to the 6. I know x squared times x to the 4th is x to the 6th, not x to the 8th. Rewrite h as an expression in which secant x appears once and no other trigonometric functions are involved. We did some of these questions, and it's kind of funny how sometimes they'll just simplify to be the answer. So when in doubt, if you don't know what you're doing, they're pretty much giving you the answer here. They do want to see some steps along the way. So let me just show you the steps. Tangent x, cosecant x, cosine x. We'll do it up here. I'm going to start by rewriting tangent as sine over cosine. And then cosecant is 1 over sine. And then I'm going to divide this by cosine. Ooh, so it's close. The sines cancel, and I get 1 over cosine divided by cosine. Now, what's that? Well, dividing by cosine is the same as multiplying by 1 over cosine. So we actually end up with 1 over cos squared, which turns into secant squared. Okay? B. Solve j of x equals 4. All right, we did this on our calculator, no calculator homework. This is where we combine. We get rid of the log base 2 using a 2 to the power. Make sure it's not 2 times 4, it's 2 to the 4th, 2, 4, 8, 16. We then look to solve by factoring. We make sure we exclude any extraneous solutions. We are not allowed to plug in negatives into logs. We get -8 and +2. I'm not allowed to plug in -8, so we would say that's extraneous. We'd cross it off. All right, next one is k of x equals 7. Finally, we got some trig equations. Didn't see many of these on the multiple choice. We get sine. Oh, this is my favorite. You all stink at this one. Sine squared x equals 1/2. Sine x equals plus or minus the square root of 1/2. You guys all stink at this. The square root of 1/2 is root 2 over 2. When does sine equal root 2 over 2? At all of the pi over 4s. Pi over 4 and 3 pi over 4, it's positive root 2 over 2. 5 pi over 4, 7 pi over 4, it's negative root 2 over 2. And then C. Find all the input values of the domain of M. Ooh, that yields an output value of cos inverse 3x. it immediately gives us something that we have to figure out. This is no calculator. Let's say you're unsure. Take the cosine. Root 3 over 2 equals the cosine of what? What angle? Inverse cosine, like trig functions take angles and produce ratios. Inverse trig functions take ratios and produce angles. However, they only produce angles in certain quadrants. It'll always be in the first quadrant. And then if it's sine inverse or tan inverse, it's going to be in the fourth quadrant, negative values. And if it's cos inverse, it's going to be in the second quadrant. So when does cosine equal root 3 over 2? That's at pi over 6. So we're trying to figure out when does this equal pi over 6? Oh, man, great question. I'm going to multiply by the negative 3 halves. Like, again, you guys gotta figure this out. Oh, I don't like how I wrote that. It's 5 root 2x, not 5 root 2x. Multiply by 3, divide by 2. That becomes pi over 4. That's fun. Negative pi over 4. Oh, this is great. Take the sine of both sides. You get 5 root 2x equals the sine of negative pi over 4, which is negative root 2 over 2. I get negative 1/10. Divide by root 2. The root 2's cancel. Divide by 5. Cool. Tough. All right. Next. Okay, write it as e to the ax plus b. So we're going to use our exponent rules. Power to a power, we multiply. When we're multiplying, we add. This is very much just like log properties. When we divide, we subtract. If you need to write these down, do it. So it'd be e to the 11x minus 1. Okay, we want to get tan x. This is sine squared plus cosine squared equals 1. Turn it into secant squared, divide everything by cosine squared. We get tan squared plus 1 equals secant squared. 1 minus secant squared. Careful, it'll be negative tangent squared. So this is negative tangent squared times tangent, which is negative tan cubed. This question is going to be where a lot of the C's, B's, B's, A's get separated. Like whoever jumps in and really figures out this question, good for you. You'll get your A on your final test. Some of you, if you don't actually do your homework, you're going to bomb this question. Guaranteed. When does J equal 3? Okay. You got the log base 2 of x squared plus 3x minus 10 equals 3. Take 2 to the power of both sides. get x squared plus 3x minus 10 equals 248. Get x squared plus 3x minus 18 equals 0. Get x plus 6, x minus 3 equals 0. I get x equals negative 6. Nope. Get x equals 3. I can check. Log base 2 of 1 is 0. Log base 2 of 8 is 3. Works. Next. 2 sine x cos x plus sine x equals 0. Factor out sine x. 2 cos x plus 1 equals 0. That's when sine x equals 0 or cos x equals negative a half. That's when 2 cos x plus 1 equals 0. You subtract 1 and divide by 2. What do we talk about? Including 0, not including 2 pi. So x equals 0 and pi don't include 2 pi. Cos x equals negative a half at 2 pi over 3 and 4 pi over 3. Let's think about the triangle where the adjacent is a half. That's the pi over 3. We need the pi over 3 when cosine is negative. That's the second and the fourth. So 3 pi over 3, 2 pi over 3, 4. You don't have to put them in order. They don't say that at least. Okay. This is a good question. I don't know if I can bring that 2 down. It's like if I had 2 log x, I'd bring that 2 up and it's log x squared. But if I have log x squared, that's not log x squared. It's log of 2x times the log of 2x. This is just a little bit funky. I don't think I've ever seen something like this. And I know, like, we want to divide by the log of 2x, but doesn't really help me. I'm a little bit at a loss here. I'll do a little bit of investigation. Yeah. If this is great. This is awesome. I don't think I've ever seen a problem in this kind of form. If you were asked to solve this equation, what would you do? You'd factor it. That's what we got going on here. Great. Great. So this is x minus 3, x minus 1. Man, great. Great question. This is log 2x minus 3 times log 2x minus 1. When does that equal 0? Fascinating. Okay, so that's when log 2x equals 3. That's when log 2x equals 1. Take e to the power of both sides. 2x equals e cubed. X equals e cubed over 2. 2x equals e. X equals e over 2. Woo! Great question. Way to go, whoever wrote this question. I haven't seen that. Nobody's getting that. Nobody's getting that. All right, nice. Couple more. I'm having fun with these. This has been my favorite. Been tricky. Oh, usually it's simplify, but it says solve. Okay, so we're changing the order. So I got 8 to the x times 8 to the 2x over 8 to the 5th equals 1. There's lots of different ways to do this, but it's probably best to do 8 to the 3x minus 5 equals 1. Now, that's when 3x minus 5 equals 0. You could take the log base 8 of both sides. However, you're expected to know that 8 to the 0 power is 1. You're expected to know log base 8 of 1 is 0. So x equals 5/3. Another good question. Are there other ways to do that? Yes. Probably the better way to do it is actually rewriting this as 3x, multiplying by 8 to the 5th, and then you have the same bases. So you just have 3x equals 5. I probably would do that. Okay. H equals 2, so log base 4 of x plus the log base 4 of 5 equals 2. That's the log base 4 of 5x equals 2. I'm going to take 4 to the power of both sides. That's 5x equals 16. That's x equals 16/5. Okay. Sine. It's always safe to rewrite it as sines and cosines. Dividing by cosecant is the same as multiplying by sine. So make sure you see that or you know it. Are you sure they want powers of sine and not tangent? So what else we stumped on? Okay, well, let's see what we can do. I have sine cubed, I have cos cubed, and another cos. If I wanted to do that. So that's tangent cubed times secant. There's no addition, so there's no like common denominators I can do. They want to turn this into just sine? I'm starting over. I don't think I did anything wrong though. I'm thinking about changing this to 1 minus secant squared, but then it's like secant's. I don't think this simplifies. Let's see if that gets typed in the right way. Yeah, this is, they screwed up. I'm certain they screwed up. Close off Google Chrome. Delete my video. I didn't delete my video, but I've combined two videos now. Yeah, I think this needs to be cosine squared. I think what happens is you do sine squared over cosine squared, and then you're multiplying that by cosine squared, and then you're multiplying by sine x. And the cosine squareds go away, and it becomes sine x cubed. I think this is wrong, so it is. We got sine 2x times sine x. Now, that's not sine 3x, so don't think that that's it. Best thing we could do is use the double angle formula. Remember sine, cosine, cosine, sine, cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. If it's sine, cosine, cosine, sine, turns into 2 sine x cos x. Times sine x becomes 2 sine squared x cos x. What are they trying to do here? This turns into cos x and no other trig functions. Okay, fine. Let's replace sine squared. Sine squared plus cosine squared equals 1. Sine squared equals 1 minus cosine squared. So We got 2 times 1 minus cosine squared x times cos x. And that's fine. Like, that's an expression involving cos x and no other trig functions. So if you wanted to simplify it, you could have 2 cos x minus 2 cos cubed x. But that's fine. Okay. When does cos x plus root 3 minus sine x plus pi over 6 equal 3 halves? Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Cosine x, cosine pi over 3. Same sign, no, opposite sign. Same sign with sine. Opposite sign with cosine. Sine x, sine pi over 3. Minus this quantity. Sine, cosine, same sign, cosine, sine. I don't even know if this is the right approach here. Gosh, what? Who made this problem? It's just incredible how this works out. No. Oh my gosh, this is great. Unbelievable.
Are you doing a video? Oh,
Whew. All. All.
great question.
Yo, you guys got to try these number 4s. Whoo boy, they are doozies.
I'll just take the 0.
Don't take. It's going to be a test grade. It's going to be a separate test grade.
So if I get 3 out of 4, that's a 75 as a test grade,
Yeah, that's what it is.
but that's a 5.
Not up in here.
What?
Not up in here is a 5. We have higher expectations.
What do you mean? Like it's not.
Do you think every student here is just going to punt on number 4?
Yeah, maybe.
No.
I feel like 50%.
Oh. Cool. 2 more. All right. Rewrite log properties. Bring the 6 up. Divide. Don't try to distribute x minus 1 to the 6 and say it's x to the 6 plus 1. You know there's a lot more stuff going on. I mean, what am I? I don't see this one either. Sine squared times sine squared over cosine squared. Oh, okay, I got it. Let's rewrite cosine squared as 1 minus sine squared. So I'm going to get sine to the 4th over 1 minus sine squared. But I have to somehow turn this into sine appearing once. I'm not seeing this one either. I'm not seeing it. cosecant squared x. You're not supposed to square both sides of the equation. Well, I guess you can for an identity. This isn't purely in terms of sign. What? There's a dilation too going on, bud.
No, I know, but even if you factor in the dilation, it's still
The answer's that.
okay.
Sorry, guys. This is not a good question. I think probably they wanted a cotangent squared. I'll confer with my colleagues, but I've already conferred offline. All right. Cool. Solve for 3 to the 2/5. I got 3 to the 2x, not x squared. This is very important. I got 3 to the 1/5. Got 3 to the negative first. That equals 3 to the 2/5. I'm going to move the 3 to the negative first up. It'll be 3 to the 2x plus a fifth plus 1. 3 to the negative first in the denominator is like 3 to the first in the numerator. If you're multiplying, you add the powers. So we get this. So I get 3 to the 2x plus 6/5 equals 3 to the 2/5. Two x plus 6/5 equals 2/5. Take the log base 3 of both sides to get rid of the 3. 2x equals negative 4/5. X equals negative 2/5. Arc sine pi x minus 2 over 6 equals pi over 12. Sine inverse pi x minus 2 equals pi over 2. Take the sine of both sides. Pi x minus 2 equals the sine of pi over 2. Sine of pi over 2 is 1. Pi x minus 2 equals 1. X equals 3 over pi. All right, output value is 0. Log properties. Get rid of the log base 7. Yeah, these are good. Complicated. Multiply both sides by the denominator. Square both sides. Subtract 2x. Subtract 8. Four works. Negative 2 does not. 2 is extraneous. Log base 7 of 4 equals log base 7 of 16 square rooted is the log base 7 of 4. You know, it was probably easier to start this set equal to 0, add the 1/2, so you had log base 7 on both sides. You still would have had to square both sides though and gone from there. So, anyways, other ways to do the same question, and that's okay. All right, last one. Let's see if we can actually do all the parts on this one, because we could not do that before. And I don't think they're gonna give you anyone that is like super hard. You'll see on your actual test, which is an actual AP College Board test, the simplification of something like that is not crazy. So, when does this equal -4? Okay, that's no big deal. Divide both sides by 2. We get secant x minus pi over 3 equals -2. Secant equaling that is the same as cosine equaling -1/2. Pi over 3 triangles, cosine being 1/2. We want the pi over 3's where cosine's negative. So that's, again, 2 pi over 3 and 4 pi over 3. My angles are x minus pi over 3 equals 2 pi over 3 and 4 pi over 3. My solutions are pi and 5 pi over 3. It's adding a pi over 3 to everything. And those are both in that. Pi minus pi over 3 is 2 pi over 3. The secant of 2 pi over 3 is -2 times 2. All right, cool. When does h equal 1? Log properties. Get rid of the log. If this was an inequality, don't multiply by x plus 1. If this was an inequality, move everything onto one side, find the zeros at the top and the bottom. Since this is not an inequality, we can just multiply by x plus 1. And it works out. -1/2. That works. It works because 3 of 3/2 minus 3 of 1/2. That's how it works out. Yeah, that equals 1. Say that. What?
You Isn't it supposed to be shifted up one? No, it's shifted up.
There's other stuff going on besides 1.
Okay, but it's supposed to be a -1. Because it's -2 plus 1 is supposed to be.
There's other stuff going on besides the +1. There's a 2 there. Okay, secant, cosecant. Let's see if this one works out. Sine over cosine plus cosine over sine. We need a common denominator. So I'm going to multiply this one by cosine over cosine, and this one by sine over sine. And I get sine squared x plus cosine squared x over the common denominator of my sine x cos x. Sine squared plus cosine squared equals 1. So I get 1 over, see this one finally works out, sine x cosine x, which equals the product of cosecant and secant. This is what we were talking about. Like sometimes it just works out that you get the answer that they tell you you should get. All right. Log properties. Okay, log properties. Big fraction. The x cube's up top. The 2x minus 1 is up top. The x plus 4 to the 1/2 is on the bottom. I don't see anything that I'd want to simplify after that. You can't distribute the 1/2 power, so don't try to do that. And just leave it like that. Oh, I'm so glad that they are doing this one again. If I were to solve this, I would take the square root of both sides. And when I do, I get plus or minus the square root of 1/2, which is the square root of 1 over the square root of 2, which is the square root of 2 over 2. Now, somehow sine plus cosine equals the square root of 2 over 2. I actually don't think that's the way to do it. I think it's distributing. Sine squared plus 2 sine x cos x plus cos squared. Yep, that's it. Sine squared plus cosine squared is 1. I got 2 sine x cos x plus 1 equals 1/2. I got 2 sine x cos x equals -1/2. I got sine x cos x equals -1/4. Two sine x cos x equals negative a half. That's sine 2x. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Sine of x plus x is 2x sine x. 2 sine x cos x. Ooh, this one's tough. So this turns into sine 2x. Yeah, equals negative a half. When does sine equal negative a half? We want the short 30, 60, 90 triangles, the pi over 6s. We want the short 30, 60, 90 triangles in the third and fourth quadrant. So that's going to be 7 pi over 6 and 11 pi over 6 plus 2 pi n, where n is an integer. Divide everything by 2, you get 7 pi over 12, 11 pi over 12 plus pi n. Make sure you say n is an integer. I'll say this, that was too hard. I don't think they're going to put that on the test. Some of the simplifications of the trig identities, a little too hard. From what I've seen, I like these questions. I thought these were very reasonable. Something like this. The ones where I was like, woo, those are too hard. Hopefully you'll get ones where you can simplify. I think they're going to be easier. So trust us when I say your quiz is probably going to be more straightforward and you don't have to worry about the super hard problems. But some things we got to remember is our double angle formulas. We have to remember the sum difference stuff. Make sure we understand our log properties, our exponent properties. Question 4 is the hard question of the AP test. I think that's what we can expect. So if we're going to really prepare for the tough part, you prepare for question 4. All right, that's it.